Good morning. So what I want to talk to you today about is doing something called analog write and PWM. And to get us started, let's look at an example that is totally not analog and no PWM at all. We're just going to have two lights flashing. Okay. And what I want to demonstrate here, I think most of us are very familiar with. Okay, I've got two lights, the left to right LED, hooked up to two different pins, 23 and 14. And I've set them to output, and of course I've opened my serial window. And this is the important part that I want to sort of pay attention to. The first thing it does when it enters the infinite loop is it tells this pin to go high, okay? And then it goes off and does something else. Well, in this case, it's going to be flashing this other LED on and off for 20 times. And then it exits this for loop, and it turns the light off for half a second. And then it repeats itself, it turns it on. So it's important to realize, and I think I've stressed this before, that the state of the pin doesn't change until you actually explicitly say, hey, change. So we set it high here. It's going to stay high and let you do whatever it is you want, okay, until you tell it otherwise. And then it goes low, okay, it goes briefly low. And if we could look at that and see what it actually looks like, believe it or not, actually just off your view, there's another motherboard sitting there with a teensy on it. And I have another program running, which is collecting data and displaying it on my computer here. Now this is really, really slow data, and currently it's not hooked up anything. So I'm going to move this wire to where the one is flashing. Okay? And you can see that it's going ahead and it's collecting data. All right. This is 3.3 volts right here. I know the scale goes up to 1200, but this is a 10-bit resolution, which means the maximum value it'll get is 1023. So it's going between 0 and 1023, or 0 and 3.3 volts, and it's generating the pulses. Of course, it stops and starts generating the pulses again. Nice straight lines, really quick, fast, okay, and then flat on top. So, with that being said, it's important to realize that this is digital. We're digital write, which means they're nothing more than on or off. Now, wouldn't it be cool if I could somehow dim this light, okay? Make this light a little bit dimmer, because let's say, for example, I had this hooked up to a motor. For example, like some of you guys know, I have a homemade electric car. Here you can see it in my garage. All the batteries, you can't see the motor, but we can barely see the little plate right there. There's a motor right there. And not only actually I'll show you what it looks like now that it's fully put together as my electric car. And it would be kind of hard to control an electric car if all I could do was turn the motor on full blast and off, right? You could imagine that would be a very, very difficult thing to do. I need to be able to somehow set the speed of the motor so that I don't take off from every stoplight with my wheels burning. So, the way they do that is with pulse width modulation. We send pulses out that will turn the motor on briefly and then turn off, and turn on, turn off, turn on and turn off. That is actually the way we get sort of a nice line going up, okay? Because right now it's just on or off. I want to be able to generate a nice line of voltage. I want to be able to make a line going from 0 to 3.3 volts, or in the case of my car, 0 to 72 volts, and be able to adjust the speed of the motor. Well, that's really hard to do with digital electronics. So they came up with a way which is called PWM, or pulse width modulation. It's many years ago, it's a standard, that allows us to pulse on and off in such a way that you can't really perceive that it's digital. Much in the same way that, for example, if you listen to your iPod or whatever electronic device, listening to MP3s or whatever, it's just pulses on and off, but they do it at such resolution, such speed, that you perceive it as a sound, as nice and fluid. Okay? So let me change this a little bit and we'll join you again in a second. Okay, so here's that program again we were just running, and what I'm going to do is I'm going to change, instead of the delay being 200, let's make the delay 1 millisecond and 19 milliseconds. Okay, so the LED will be on briefly for 1 millisecond and then off for 19. And we'll load this up and see what it looks like. I'll pause it while it's loading. Now this is kind of different, and I'm going to show you this. You can see that I have this light is quite dim, but you see how it sort of flickers? Okay. Oddly enough, I can't see that flickering with my eye. All right, you can see it with the camera. That's because it actually takes a brief period of time for the LED to start getting bright. All right, and this camera is running at a frame rate, and every so often it's capturing the light completely off. So you see that sort of flickering. But if I was looking at it with my eye, I would not be able to perceive any sort of flickering. I'm going to clean this up a little bit, get rid of this other flashing light. We'll take a quick look. Okay, here you can see I've just commented out the turning off portion of this LED. And you can see that this light is pretty dim. That was actually solid. Now it's starting to flicker. So you can see that's a frame rate issue. And then it'll stop and we'll see a nice, smooth, dim light. But clearly this light is dimmer than this light because we're turning it on for only a fraction of a period of time. Okay? So let me move on to the next thing and we'll go a little bit further with it. Okay, the original piece of code is still running here. I just want you to see these side by side. Let's say, for example, I want to have a light that's held dim while the other one's flashing. Okay? Well, you can see the dimming process here is what's consuming all the resources. Okay? It's stuck in this for loop. I can't ask it to do anything else and continue to hold the light dim if I use this digital write method. It just won't do it. All right. If I do something else in here, let's say, for example, turn on and off this light, this is going to stop reacting. I can't do multitasking of this nature. So if I do want to have a light that's held dim, and then I want to do something else, okay, I need a new strategy. Okay. Well, that new strategy, okay, here's the original. That new strategy is, well, let's put out an analog value to the left pin, okay, this one right here, and hold it dim, and then let's make this one flash, and then we'll turn off that light. Now I should stress, analog write is a in this argument right here, it goes between 0 and 255, and I'll show that in a second here. 255 is going to be its highest value, all right, and 0 is going to be its lowest value. So by doing it at 20, I'm actually going to have the light rather dim. And I'll try to show it to you graphically here in a moment as well. So let me pause it, load it up, and let's take a look. Okay, so take a look at what we've got right here. This light is currently held dim. Okay, it's nice and steady, and it turns off again. So I turn it on to a value of 20, which is out of 255, so it's a rather dim light. And then I go off and do something else, which is flash this light, and it doesn't go off. It stays dim. This is running completely independently of this, entirely in the background. And again, going back to my electric car analogy, could you imagine how bad it would be since my electric car is a digital system, and I was driving down the road and I had my accelerator down a little bit of a ways, and the motor is moving at, say, 30% of its maximum speed. And then I turn on my turn signals and suddenly I lose control of the speed of the car. That would be undesirable. Okay, so by having analog write kind of independent, it'll hold the function until changed. So it's going to hold it at 20 and continue to pulse and until we tell it otherwise. Let me see if I can show that sort of graphically here. I'll be right back. Okay, so here you can see this yellow wire is hooked up to the other teensy, and it's displaying the flashing on and off of this light. Now remember I said this is a really, really slow display, and this thing is flashing at phenomenally fast rates. Okay, and I'll explain a little bit more here shortly, but it's basically pulsing on and off in less than 2 milliseconds at the top, way faster than this graph is displaying. So if I move it over to this one, where the analog is, we get a lot of data, but it's difficult to interpret because you can see something going on here. You probably see when a light goes off, there it is, okay? But this is indecipherable mush, okay? So let's say, for example, since I can't display this data very well at all, what if I averaged? If I took 100 samples and then averaged it, all right, then maybe we'll be able to see a tendency out of this data. So you can sort of see something here, but it's pretty hard to do. Let me go ahead and pause this and do a little data averaging. Okay, so now what I'm going to do is I'm going to take 100 samples and then plot them every few milliseconds. So here you can see the average of 100 samples, and it hasn't really changed much because I'm hooked up to the side that's flashing. All right, so we're getting that nice sort of square wave that we've seen before because it's just on or off. It doesn't matter. An average of 100 3.3 volts is still going to be 3.3 volts. And an average of 100 0 volts is going to be 0 volts. So now let's go over here and plug it in here. And you can see we get quite a bit of a different set. Okay, oops, it's rescaled. Let me go back over here and scale it back down. Okay. So now you can see that it's quite a bit smaller, quite a bit lower than the original data set. Move back. Okay, that peak is 3.3 volts. This peak down here is probably, I don't know, a volt. All right. In fact, you can see a little tendency in that wave there of it going up and down. Even though it's averaging, you can still sort of see a wave pattern. All right. So let me change this a little bit more, and I'll be right back. Okay, so take a look at this code. Remember I said the maximum value was 255? Okay. So what I have here in this main loop is I have turned on, of course, the right LED. And then I created a loop here that goes from 0 to 255, incremented by 1. And then I stimulate the left LED, or tell it to analog right to that left LED with those values. So it starts with 0, then it goes to 1, then it goes to 2, each time delayed by 5. And it counts all the way up to 255, and we see the light get bright. As soon as it reaches 255, it exits this for loop right here, and it jumps to the next one. In this case, I tell it to start at 255, work its way down to 0, once again inserting the value, and you can see the light gets dim. Okay? Well, what does that actually look like? Let's take a look at it graphically here. All right. So currently, this yellow wire is connected to the one that's just pulsing, and you can see we're getting our 0 to 3.3 volts. This is, by the way, is still averaging. It's taking 100 samples and then displaying it. Now, if I move it over to this one, you can see that the average of 100 samples gives me a nice sort of tendency. So you can see the voltage going up and then down and up and then down, corresponding to the dimming and brightening of the light. Okay? So that is how you would control a analog device like a light with a digital signal. All right? I'll show you one last thing in these last minutes, and I'll be right back. I thought you might like to hear what that sounds like. So here I've taken and plugged in the buzzer in replacement for the LED. And I still have it running through the resistor, so it's not so noisy. But you can hear that it's fading up and down. It is extremely important to point out that not every pin is capable of doing analog right in PWM. In fact, on the chart, you can see it's only these pins. No other pin will work. Okay? So in this case, I have the tricolor LED plugged into these top 3 pins, 23, 22, and 21. Let me dim this, and you can see it. So this ends in seconds, so I'm not even going to explain it. You guys can pause it and see if you can figure out how I make it dim to the 3 colors. See you soon.